Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Heyawake Sudoku by Senny K. And here are the rules. We have chaos construction rules where we need to divide the grid into 9 orthogonally connected 9-cell regions, draw their borders, and place the digits 1 through 9 once in each row, column, and region. So what is an orthogonally connected region? It's something that where you have to have cells in all that region must be able to travel to another cell in that region just by going through edges, all while staying within the region. So this is an example of a valid orthogonally connected region, because to get from here to here, you can just go through edges, all while staying within the region. This, however, would not be a valid region, because these two cells, even though they can get to each other by going through edges while staying within the region, they cannot get to the other cells in the region by just going through edges while staying within the region. They would have to go through a corner here or go outside of the region, which is not allowed. So that's an example of how chaos construction, specifically orthogonally connected regions, work. We have white region dots, where its digits in cells joined by a white dot are consecutive and belong to the same region. So for example, if this were, say, a 6 here, this would have to be 5 or 7, and they have to belong to the same region because there's a white dot between them. We have black region dots, where in digits in circles joined by a black dot are in a 1:2 ratio. That is, one digit it will be double the other, and they belong to different regions. So for example, if this were a 2, this would have to be 1 or 4, and they have to belong to different regions because there's a black dot between them. And that's an example of how the white and black dot regions work. We have circles, where digits in circles indicate how many cells of their own region, including themselves, they see orthogonally. And region borders block vision. And each circle belongs to a different region. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 circles. There's nothing about uniqueness about these digits, so they could be repeats here. But if this were to, say, have a 6, that means this would see 6 cells in its region orthogonally, which means basically in a horizontal and vertical direction. So say this green was part of a region, then this would have to see 6 cells. So it could be something like this. And then I guess it could be part of that, right? And that would be 1, 2, 3, 4, 5, 6, 7, 8. And then that would be, you could do something like that. So this would be valid because it sees 6 cells in its, well, it can't be that one, but I guess it would be that one. Because a circle belongs to a different, each circle belongs to a different region. So there's one circle per region. This sees 6 cells, it sees itself, it sees 2, 3, 4, 5, 6, and it's blocked by other region borders. And this again, the circles count how many cells of the region that it sees. And each circle belongs to a different region. We have 9 circles. So each one must have 1 circle. We have Heyawake, where we need to shade some cells so that no 2 shaded cells are orthogonally adjacent, and the remaining unshaded cells form one orthogonally connected area. There cannot be a horizontal or vertical line of unshaded cells that goes through 2 or more region borders. So, right. Hmm. This is a little problematic because of I only have 9 colors, but there has to be a shading too. So for Heyawake, the shaded cells, again, cannot share an edge, essentially. So, and, um, hmm. in addition, you cannot have, so if these were the regions, and we didn't have a shaded cell here, that would mean this has to be a shaded cell here. Because a horizontal or vertical line of unshaded cells can only go. You cannot have it go through 2 or more region borders, right? So this would be, for example, say we had a shaded cell here, it would be the same thing. We would have to have a shaded cell there because you can't go through 2 borders of a completely unshaded cells, which the coloring here throws things off, which is why it's like there's shaded on top of regions. Um, um, but you can't have fully unshaded cells, which these are. You can't have essentially a horizontal line or a vertical line of those cross through 2 boundaries, 2 region boundaries. So that means again, if none of these were shaded, this has to be shaded here, guaranteed, because this is a cell, this is a 9-cell region, this is a 9-cell region, so this is a boundary here, and this is a boundary here. So therefore, you cannot go all of these unshaded because it would cross 2 region boundaries. And again, remember, the shaded cells cannot share an edge with any other shaded cell. And those are the Heyawake clues. We have squares, where digits in squares indicate how many cells of their own region, including themselves, are shaded. Interesting. And each square belongs to a different region. Huh. So that means we should have 1, 2, 3, 4, 5, 6, 7, 8, 9. We do have 9 squares in the grid, and they indicate how many of the cells in their region are shaded. So, for example, this would be part of this region here, and it only has right now 1 shaded cell. So this would have to be 1 if that were the case. And finally, we have shaded cells, which are the 3 red shaded cells in the grid have been given. Digits in the remaining shaded cells are greater than at least. So these red shaded cells are given. Digits in the remaining shaded cells, which are not these 3, are greater than at least 2 of their orthogonal neighbors. The rule does not apply to the given red shaded cells. So if we ever have, well, we have to have another shaded cell, but say we placed a shaded cell here. This would have to be greater than at least 2 of the cells that share an edge with it. So 2 out of these 4 cells. It would have to be greater than if we placed a shaded cell there. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, let's place some boundaries. We know this is a boundary, this is a boundary, this is a boundary, this is a boundary, this is a boundary. Because squares cannot be in the same region, circles can't be in the same region. This has to go this way. This must go this way, and then it goes this way because it's blocked by this cell. Because circles cannot be in the same region. This has to go this way, so we'll make that green. I guess we'll make this red here. Light has to go out this way. Medium has to go out this way. Okay. So we have region border here, region border here, here. This is going to be dark. So this is boundary here. That means medium has to go here. And these are in the same region because of the white region dot rule. They belong to the same region. Therefore, dark has to go that way. So we have a square and a circle here. So this is boundary there. We need a shaded cell in one of these cells. We don't know where. Okay. This gray cell, okay, circle, see how many orthogonally connected. Okay, so this light cannot go here because this is the same region as this. And you'd have two circles in that region then. So this must go light that way. Green has to go this way then. Red has to go that way. So we have boundary, boundary. This is a boundary, guaranteed. This is a boundary because, or not this one. But this one is a boundary here because then this region would have two circles in it. So we're going to make that pink. We have 1, 2, 3, 4, 5, 6, 7 light cells. Green has to go this way. Red has to go this way. So boundary, boundary. Medium could go that way. We have 1, 2, 3, 4, 5, 6, 7. We need access to the square, so this has to be the square that it has access to. And it goes either here or here. Green cannot go, well, green could go here, but it has to go here too. So this is green, which means red has to go that way. Green cannot fully go here because then red doesn't have a full 9-cell region. So we can have 1, 2, 3, 4, 5, 6. Green cannot go here because that's a circle. Green can't end here, so green has to go that way, which means this has to be light because it can't be green here. And this would only be green or light as possibilities. Light is done as a region. Green is done going that way. Green has to have access to a square. 1, 2... Oh, wait, no, this is... No, never mind. Never mind, never mind, never mind. Light cannot go here because this is a square also. So then 1, 2, 3, 4, 5, 6, 7, 8, 9 at least. So this is light and this is a boundary. Right, this is a square too. So we have square, circle. This is both square and circle. Its circle sees how many orthogonally. So this must be 3. That's 3 in the corner. We celebrate because, I don't know, we're somewhat on the way. Green, again, cannot, though, go here. It can't block off red. So green has to go... Well, green could go that way. Huh. Interesting. This is... Oh, this is square also, right? Is it square? 1, 2, 3, 4, 5, 6, 7... Yes, this is square. So this is boundary there. Oh, this is square and circle. So it cannot be part of this. We're going to make it yellow. Green could go through here. This is 2 regions. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So yellow cannot go both this way. So yellow has to go around that way. This is boundary here. We'll make that blue. Blue goes this way. This is boundary here. This is boundary here. Yellow, there's no way yellow can have this many cells. No, it'll block off red if that's the case. These have to go out somewhere. This circle has to go out somewhere, and therefore these are the same region. We'll make this, I guess, orange. And therefore this must be part of red. Orange has to go out. So yellow goes here, blue is here. We have, therefore green cannot go this way. Green has to go this way. So therefore this is done. We have 1, 2, 3, 4, 5, 6, 7, 8 at most. So green has to go out that way. Orange has to go out this way, so this is both orange. So this is boundary there. We have 4 more here. So this cannot be green. If this is green, that's too... this can't have 4 reds. So this can't be green, therefore there's boundary there. So this must be red. If it's not red, then you can't have 4 reds orthogonally connect to this. So therefore this is red here. Orange could be any of these 3. This is guaranteed to be red. So we could have red here or orange, and yellow could also be here. So yellow has to go out, so that's yellow. This is blue. We have 1, 2, 3, 4, 5, 6, 7. This is 1, 2, 3, 4, 5, 6, 7, 8. That means we need one more as a 9th. So green has to go out that way. Orange has to go out that way. Yellow has to go out that way. That's blue. Blue has to go this way. Yellow has to go this way. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is the maximum. We have only one orange here. 2, 3, 4, 5, 6, 7, 8, 9. So this is orange. This is green. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's green there. So that's done as a boundary. Okay. So let's remove the light. Green is done as a region. So let's remove the greens. Orange, yellow, we don't know. Blue has to extend out. So we have 1, 2, 3, 4, 5, 6, 7, 8. This is boundary here. Boundary here. And blue could go here or it could go there. We don't know which. That means pink has to go sort of this way. Okay. Circles, again, sees how many cells they're orthogonally regions. So this is 2. This sees at least 5, 6. So it could be 6 up to 7. So it's 6 or 7 there. Okay. This has access to a circle or a square. This is square and circle, so this sees 2 or it sees 3. We're not sure which. This sees 4 in its region. This sees 2 or 3. This sees, we don't know. This sees at least 4. At least 4. And up to 8. This must be part of a circle, so it has to be there. And it can't be part of this region here, so it has to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that has to be there. So that's done as a region. So this is, we can remove that coloring. Pink has to access this square. So we have if this is medium here, that would cut off. So this has to be pink. Orange, we have 1, 2, 3, 4, 5, 6, 7, 8. This could be orange. This could be yellow. or blue. This could be blue. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So pink could access any of these. Pink cannot access these. Pink could access here. We have 1, 2, 3, 4, 5, 6, 7, 8, and it cannot cut off here. So this cannot be. I guess this could be medium. So medium can go all the way up to here. Pink has to be these 3 though, or these 4, I guess. This has to see at least 4. So 4 through 7 could be pink all the way there. Actually, this has to be pink here. So we have 1, 2, 3, 4, 5, 6, 7. We need to connect orthogonally to here. So 1, 2, 3, 4, 5, 6, 7. It cannot, it has to be 1, 2, or 1. It could be 1, I guess, in that way. So this cannot be pink. If this is pink, well, actually it could be 1, 2, 3, hold up. 1, 2, 3, 4, 5, 6, 7, 8, and 9. But then the problem is this is 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10 as a region, which is not allowed. So pink cannot go here, which means this is blue, which means this can't be blue here. So this is done as a region. This sees 3 cells, so that's 3. Blue is done as a region, so we don't need blue. If this is pink, one of these is yellow or orange. You cannot have both, though, because if both are, we have 5 reds here, which have to be part of red. So if this is pink, can that work? 1, 2, 3, 4. If this is pink, that means yellow's here. Red has to be these 4. So then orange is up to here, which means this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this cannot be pink, which means that's yellow, which means no yellow there. So that's 1, 2, 3, 4, 5, 6, 7, 8, and 9, which means this sees 2 cells. This cannot have yellow, so this is red or orange. We have 4 reds, 1 orange, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this cannot be orange, it's pink. So we have 1, 2, 3, 4, 5, 6, 7, 8. This sees 6 cells, so that's 6. And one of these is pink. We don't know which. This sees 4 cells, 5, 6, 7, maybe. No 8. So we got the yellow. Okay. This is boundary here. 2 is in a 1-to-2 ratio with 1 or 4. This has 3 shaded cells in it. This has 2 shaded cells in it. Okay. This is in a 1-to-2 ratio without a 3. So this is 1, 2, 4, 8. No 2 here. So this can't be 1 in that case. These are consecutive. Okay. This has a, I mean, obviously there's at least 1 in every of the squares. Hmm. One of these three is shaded here. We don't know which. This is consecutive. 6 is consecutive with 5 or 7. This is consecutive with 3 through 8. No 6 here, though. That seems fine. Red needs access to a 2, so red has to have a 2 in one of these 3 cells. Okay. This is in a 1 to 2 ratio. Therefore, it's any of them. It's pretty broad. This cannot be 3 or 6, so it's 1, 2, 4, 8. Okay. This can't be 4. Um... Now we need to do the Heyawake shading. Oh boy, that's gonna be crazy. Let's see. Okay, so this full thing doesn't have to have any shaded cells. We need 2 here, at least. Uh, hmm. Okay, I'm gonna remove the coloring. Ugh. Okay, let's make these lighter shades. So we're gonna make this green. Instead of pink, I guess we'll make this orange. This is a shaded cell. Okay. We'll make this yellow. And I guess we'll make this blue. This sees 2. It has 2 shaded cells, and these cannot. So these cannot be shaded. Not sure how to designate that. Maybe not make this green. Let's make this pink, I guess. I don't know. Green means no shaded. Okay. So this satisfies both these directions, so we don't necessarily need another shaded cell here. There's only one more shaded cell here. That's interesting. So there's only one more shaded cell in this region. How many shaded cells is this? This is 1, 4. How many shaded cells can you have in a region? I think it's 5 at most, right? You can, yeah, because you can't share edges. Oh, I forgot to really highlight that the unshaded cells must form one orthogonally connected region. That's pretty important. But anyways. So we know this is red. These are red. So those are the shaded cells. So you can have 1, 4, or 5 in the shaded as a shaded cell. Can you really have 5 though? 1 shaded, unshaded, shaded, unshaded, shaded. unshaded, unshaded. One. So these are all unshaded. And then you could have shaded here or shaded here. So we have 4 unshaded, 3 shaded. I guess that's possible. Up to 5. Yeah, so I think the squares have to be up to 5. So you cannot have 8 here. This is 1, 2, 5. 1, 2, 3, 4, 5. 1, no 4, no 3. 1, 2, 5 also. And this cannot be 2 or 3. 1, 4, 5. No 2. 1, 3, 4, 5. Okay. How many shaded cells do we need per row and column? I guess is what I'm sort of looking at. Here we need 1. Here we need 1. Here we need, that's 1 region, 2 region, 3 region, 4. We need 2. So that's already, that's minimum of 4. Here we need 2. That's 6. Here we need a lot. Oh boy. So 1, 2. Or we have bound, shaded, shaded, shaded. We need 3. Okay, so I don't know where to put these. Here we need. Okay, let's. Ugh. No, I don't know where to put these. 1, we need. Do we need 1? We need 2 here, right? No, this is 4. Yeah, we need 2. So this needs 2. This needs 2. It could be 1. Well, this is all orange. You need 2, even, right? No, you need 1 if this is all orange. Oh, but one of these is not orange. One of these is pink, at least. Ooh, so you could have orange, pink, orange. So you need 3, right? No, you just need 1, actually. Huh. Because you have 2 there. You could have 1 pink here, which then goes to orange. And then the pink, as long as the pink is the shaded cell, that's okay. So that would be 1 in that case. That's interesting. These are 5. You could have 1 here, and that would work too. So you could have, you need 1 there. Here is a lot needed, right? You could have, you either have 1 here or 1 here. Even if you have 1 here, that's 2 there, so you would have to have 1 there. So I guess you have to have 2 at most there. Or at least, I should say. Here, we could have 1 there, so that's 1. Huh. This, we have yellow, then blue. And then you could have there, so that's 1. Yellow, blue, blank, and then that's, so that's 1 also. And this has to have 1. So not many that require 2. Okay. I mean, actually, this could require only one also. Huh. So we have one required except for this one, which requires two. Definitely. So that's 10 that are required. Oh, okay. What about columns? Uh, so these cannot be shaded. We know that for certain. Hmm. Um. Hmm. One of these, so one of these three is definitely shaded. Because if these two aren't shaded, that's two boundaries that would go, one boundary it goes through, it cannot go through a third. If these two are unshaded, same thing. And this could be shaded either also. So one of these three is shaded. We're not sure which. Um um hmm. You could do green. Okay, this cannot be four. It has to orthogonally connect to one of these two at least. So this is 5, 6, or 7, which means this can't be 3. You could have 5 if it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. It can't be 9. So you can't have 5 either. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would see 6. So this can't be 4 there. Um, hmm. It could see 7. Can it see 7? 1, 2, 3, 4, 5, 6, 7, 8. Yes. And then 9. Or 9. Or one of those. We have to have two pinks here, at least. So then this has to actually have two shaded cells, right? Um, hmm. Interesting. Oh, column 5 is hairy. Um, you could have shaded cell here. We know that's shaded. So we need one here. We have two here. Um, if it's orange and pink, this has to be shaded. So what happens if these are 5 is another question, right? So say this was 5. Then this would be, this would have to be shaded, 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 and shaded. These would all be unshaded. Oops, not red, green. All unshaded. Um, I mean, it's possible. Hmm. You would have to have one of these be shaded. Um, Same if this is 5, right? If this is 5, we know these are shaded. Oops. Oh, that doesn't work. This cannot be 5. Well, that's good to know. So this can't be 5, because if we have 5 here, the shading would be weird. So it would have to be shaded, 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 and then this would not orthogonally connect to the rest of the unshaded cells. So this cannot be 5, it's 1 or 2. This cannot be 1 and 2. No 2, 3, no 3, 4, no 4, 5. It's 5 through 9 here. Okay, this cannot contain 3. So technically it could be 1, 2. Could be 4 with 5 there. 5 in the not rest of the digits there. This can't be 3, so this can't be 6 there because of 3 in the region. 3 cannot be here. 3 has to be one of these two for this region. Can this be 5? Okay, so then you'd have shading here, 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 not here, here, and that would not work. So this cannot be 5. It could be 4 or 1. Can this be 5? That's another one. We have shaded here, and then shaded here. And this would all be unshaded. That means this is 7. This can't be 5, 6, or 7. It would be 8, which is consecutive with 7. So it has to see 1 through 6, and then 7 here. So these would all be... This would not be orange. That'd be pink. This would not be orange. That's pink. And then one of these two is pink. That seems okay. This sees 6 cells. We have 7, 7 there. This must orthogonally connect to the unshaded cells. So then this could not be 5. Obviously. 5 eliminates 5 here. Remaining... This can't be 3. Oh. Where is 3 in column 4? Can't be here because of 3 in the row. Can't be here because of 3 in the region. These are not consecutive with what these have to be. And this is 6. This can't be 3 because of the blue region, and this is a 2. So this has to be a 3 here. Interesting. So there are 3... That means where is 3 in column 2? These already have a 3 in the region. We need to have it in yellow. So one of these two is a 3, because yellow needs access to a 3. So this has to be 3, which means this cannot be 3 here for the pink. Where is 3 in column 5? Well, it's not that restrictive. It cannot be here because of 3 in the region. Can't be here because of 3 in the row. Could be here. Cannot be here because of 3 in the region. Can't be here because of 3 in the row. Can't be here because of 3 in the region. Can't be here because of 3 in the row. So 3 in column 5 has to be one of these two. Okay. We are guaranteed a 3 here, though, so that means this can't be 3 here, which means this must be a 3 here. So orange has a 3, which means this can't be 3 there. Pink has to have a 3, which then is one of these two. Red, this region here needs a 3. And it cannot be any of these or here. Oh, this can't be 3. So we know yellow 3 has to be here. Okay. Which means this can't be 3, this can't be 3, this can't be 3. This can't be 3. Where's 3 in this region here? It has to be here. So that's 3, that's 6. Which eliminates 3 here, so this is 3 there, which means this can't be 3, so this is the pink 3. We have all the 3s now in all the regions. This cannot have a 6 here because of the 6 in the region. 6 is not as restrictive. 2 cannot be here. 2 cannot be here. So in this region, 2 has to be one of these 3. Cannot be here. So it's one of these 2. Which eliminates 2 here. So 2 in this region has to be one of these 6. Obviously can't be here. Which means this cannot be 2 here. This is 1 or 4. 1 or 4 then is in a 1 to 2 ratio with only 2 or 8. This requires a 2 or an 8 here, which means the rest of the column cannot contain 2 or 8. If this is 4, you go to 2 or 8. If this is 1, this has to go to 2. That's why it's 2 or 8. If this is 1, 2, that's 8. If this is 2, 4, that's 8. If this is 4, 8, that's 2. That means this can't be 2 or 8 here. So we have no 1. We have 1, no 2, no 3, 4, 5, 6, 7, 9 as possibilities. 6 can't be here because of 6 in the row. This can't be 4 because of 4 in the row. We need 2 in this region here. Again, 2 cannot be here because one of these is 2 and 8, with that being the other being 2, 8. This can't be 2 because of 2 in the column. This can't be 2 because of 2 in the column. So 2 in this region must be one of those 2. Two in this region is one of those 2. That's interesting. 2 in the yellow region is one of those 2. 2 in the blue region could be here. So if this is 2, that means this can't be 2, so that's 2. But then 2 cannot be any of these spots, 2 can't be any of these spots, and that's a problem. So this can never be the 2, which means 2 has to be here for yellow. So this is 2, and this must be yellow. So it cannot be blue, it's yellow. So this is boundary there. So there's no 2 here. 2 cannot be here, 2 cannot be here. 2 can't be here because that we had the problem with this. Where is 2 in row 8 then? Again, if we have 2 here, that means this can't be 2, so 2 is there, and that eliminates 2 from the rest of this bottom right region. So 2 cannot be here. 2 can't be any of these cells because of the 2 in the region, so 2 has to be here, which means this can't be 2 there. So blue cannot have a 2 here, or here, or here, so blue has to have a 2 there. Where's 2 then in column 2? I guess it could be either of these. So that's either of those could be 2. 2 can't be any of these. 2 can't be here, so 2 in column 8 is one of those 3. This can't be 2 because of 2 in the column. 2 cannot be here, here, here. So 2 is one of these. Can't be here, so 2 is one of these 2. So we have a 2 guaranteed here, a 2 in one of these 2. This can't be 2 because of 2 in the column. So this is 1 or 4. To be in a 1 to 2 ratio, that means this can't be 2. This is 8, which makes that 4. Interesting. So this cannot have 4 here. Two again is one of those 2. We have 2 as one of these 2, and 2. I guess 2 could be any of these 3 technically. Well, okay, where's 2? 2 can't be here, no here, nor here, nor here. So this must be 2 here. So this is 2, which eliminates 2 in the rest of the column and region. So this can't be 2, which where's 2 in column 2 then? 2 has to be here, which means this cannot be 2. So 2 is one of these 2, and 2 is one of these 2. So if this is 2, it's orange, which would mean 1, 2, 3, 4, 5, 6, 7, 8, and 9. If this is 2, then that's 2 there. There are 4 shaded regions in the pink region. That's interesting. Four. No, we already knew that. 4 had to be... Okay, so 4 cannot be any of these cells. 4 can't be here, so 4 has to be here, which means this can't be 4 there. We knew 4 had to be one of these 2, but we didn't know which one. This cell is the same as that cell. So it could be 1, 5, 6, 7, 8, 9, which matches that. This can't be 8, so this can't be 8. 3 and 4 match these 2. Oh. 1 cannot be here. It's not consecutive with 2 anymore. If this is 5, that's not consecutive with 4 or 6 there, so this can't be 5. This can't be 4. 4 could be any of these. Whereas 6 in this region here, it cannot be here or here, so it must be one of these 3 cells, which means this cannot be 6 here. This can't be 6, this can't be 6, so 6 is one of these 2 cells. 6 could be here. 6 could be any of these. 6 cannot be there, though. So 6 is part of this region or yellow. So here we have 6 as part of one of these 2 regions. 6 is part of this region or yellow. Oh, well, yes. So 6 is one of these 3 cells in this lower right-hand region. Because that's 6, that's 6. This can't be 6 here. We have yellow can only go here. Well, pink could go here. 6 in this upper left-hand region is here. 6 in the yellow region is one of these 3. It's actually one of these. Shoot. Remaining digits of row. Let's do 4. 1, 4, 5, 7, 8, 9. No 4 here. No 4 here. No 4 here. Pink doesn't have access to a 4, though. Pink has 4. So how does pink have 4 shaded cells is kind of the question. Okay, if this is not pink, then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. These are not shaded. So can you ever have 2 here? I guess if this is shaded, right? I think the answer is no, right? Well, this could be pink and shaded. That's the thing. So this has 4. One of these 2, one of these 2. If this is pink, then it includes that. So this is either 1 or 5. Oh, interesting. Can it ever be 5? So if this is 5, that means this is shaded. This has to be shaded. This must be shaded. And then none of these can be shaded, so this must be part of that. Does that work, though? So it would have to be these. This would be non-pink. So then these would all be pink. And you'd have to have 4 shaded. This is unshaded here. Unshaded, unshaded. This has to orthogonally connect out. This must orthogonally connect out. And the answer is no. That does not work. So this cannot be 5. It has to be 1, which means this is pink. So it's not orange here. That means this is boundary. This has only one. So then these are all green. Interesting. This is green also. Because this is the only non-orange. This is one. You could have two, and then this is red. That's possible. So this is all green. Okay, let's make these non-orange. And we'll make these all non-pink. So we know these are the mixes, so this will do the same thing. No blues and no yellows here. So these are the possible ones that have one. This is bound, this is unshaded. Can you have 1, 2, and 3 is the question. Okay, so let's try that. Shade, shade, and shade. And these are all unshaded. This must be unshaded to connect. This seems okay. This has 3 shaded. Don't know which. Aha! No. This is 3 completely unshaded cells, and they cross 2 borders. So no, this does not work. So then we can only have 2 of these be shaded, which means this must be part of the region and be shaded. So this is shaded, and it's blocked there, which means this is unshaded. You can't have these two, because that forces this to go that way. You could potentially have these two here. So this is shaded, that's shaded. This is pink. So we have 2 there. We have 1 out of these 2. 1 out of these 3. Cannot be these 2 specifically. So if it's here, you could have 1 here. No. So this is full. One of these 2 has to be shaded. If this is shaded, then one of these 2 must be shaded. What happens if this is shaded? So say we have this as shaded. Then these must all be unshaded. Hmm. Yeah, I'm not good with the Heyawake, so it's going to take me a while. This is 1 which eliminates 1 here, which means this cannot be 1 there. Okay. One cannot be here. One has to be one of these four. But that's not really restrictive. I just kind of want to finish this off. So one of these two is shaded. We guaranteed that. Uh, hmm. Okay. This is all unshaded. So either that's shaded or that's shaded. Hmm. This only has two, though. That's interesting. Can this have only one? That is a good question. Maybe. Remaining digits in column 4. We have 1, 4, 5, 7, 8, 9. No 4 or 8 here. This could be anything. This could be anything. This can't be 5, because if this is 5, that would force us to be 6, and we know one of these 3 is a guaranteed 6. Ugh, this Heyawake is kind of... Okay. Oh, this is green. This has 2 only. So if none of these are shaded, we know only one in this region is shaded. So if none of these are shaded, that means this must be shaded. Oh, we have shading there. If none of these are shaded, huh. Yeah, I'm not good with Heyawake, so it's just like, it's gonna be slow for me. 1 eliminates 1 here. This needs access to a 1. And it's going to have to be one of these two, because this is all part of the same region. I guess this could be 1 also. So we have 1 in one of those 3, which means this cannot be 1 here. None of these could be 1, so 1 has to be one of these 3 for this region. Okay. This cannot be part of this region. If it is, wait, no. Yes, it cannot be part of this region, because then this would go through 3 boundaries, or 2 boundaries here. So this has to be part of this region here. So then we know this is boundary. Well, actually, this could be... No. Okay, so that could be... Never mind. That could be... This could be shaded also. That could be shaded. Never mind. We have 4 here. That's 2. One of these is... I guess you could have... No. Yes? Maybe? I don't know. This is... Yeah, I'm not good with Heyawake at all. I just don't see it very easily. This has 2. This has 1 more. And this could be 1. What happens if this is 1? That means there's 1 more here. There's 2 total here. That's interesting. So this one doesn't matter. It's only 1 boundary. This doesn't matter. It's only 1 boundary. So we could actually have 2, like, here. Right? I guess that kind of works. Remaining digits here cannot have 1, 2, or 3, so we have 4 through 9. No 4 here. This is 5 through 9 there. No 6 there. What else do we need access to? We don't really need access to anything else, just this cell. So the remaining cells for this region here are this cell and a 1. But we don't have that. We need a 2 for this orange region. Or whatever this was. And 2 cannot be here or here, and this is not part of the region, because this only has 1 shaded cell, so this has to be a 2. Which means this cannot be 2 here, which means this is 2 there. That's interesting. Huh. We have all the 2s now. 1s. We only have 1, 1. So this only has 2 shaded cells. Period. This only has 1. Interesting. Obviously, this is not shaded. This doesn't have to be shaded, so we don't have to worry about that. Realistically, none of these have to... Well, okay. This doesn't have to be shaded. So these don't have to be shaded. This could be shaded. We have 2 shaded cells here, 1 more here. 1 or 4 here. Can this actually be 4 is kind of a question. We have 4 here. So we have 1 there, 2 here, 3 here. And you'd have 4 there. Right? Maybe. Nothing that great. Remaining digits in row 3. 1, 4, 5, 6, 7, 8, 9. Pretty broad. No 6 here, no 4 there. This we don't have really restricted. Where is... Well, 1 is, again, one of these 4 in this region. So one of these 2 is shaded. Right? If they're both unshaded, that doesn't work. That crosses the boundary of 2. If this is shaded... So we're... Well, okay. What happens if this is shaded? If this is shaded, this is all unshaded. Which means this must be shaded here. This is unshaded. This is unshaded. So then this has to be shaded here. So these are unshaded. This has to be unshaded here. Unshaded here. This is 2, so this has to be shaded and shaded. Which means... Interesting. This cannot be 4, I don't think, right? We have 1 shaded here, 1 can be shaded here, and 1 can be shaded here, so that doesn't work. So this would be 1, which means none of these are shaded. Therefore, that would force this to be shaded there, and we'd have 2 shaded cells being in the shaded. So this cannot be shaded here. This is unshaded, which means this must be shaded there, which means this is unshaded. This is unshaded to connect orthogonally. I think it's the same this, well, no, it's because, yeah. It's because this was shaded, which forced this to be unshaded, right? Huh. I think 1 is really restrictive. Hmm. So what happens if this is part of this region here? Then what it has to be, so it has to be like that, which means this must be shaded. Since that's shaded, we have 2. These have to be unshaded. This is unshaded. That's fine. This sees 6 cells. So this would be 6, meaning that's not 8. 5, 7 as a pair. Eliminated from the column. No 6 here, no 6 here. Okay. This seems fine. One of these 2 is shaded. That seems fine. Yeah, I'm spending a lot of time on this Heyawake because I don't know what these are. Hmm. 3 shaded here. Hmm. 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 One is one of these 2, so this cannot be 1 here. No 6 here. No 6 here. No 6 here. So 6 has to be one of those 3, which is fine. This can't be 4. Hmm. I mean, this seems fine. So, unfortunately, that doesn't help us much. This still has to be 2. We did have that. We know that's for certain. That's the orthogonally connect. That's where we don't know. So if it goes this way, then this would have to be 7, which makes that 8. Interesting. This would be green, green across 1, so this would have to be red, which forces all of these to be green. This is green, green here, so then this would have to be red, which would force all of these to be green. Okay. That seems okay too. Hmm. Yeah, that's not too helpful. This still must be green, green. This crosses 1, that's fine. This is done. This can cross 1 at most, that's fine. One of these must be shaded. No, that's not true. This could be shaded. Okay. Hmm. This digit here cannot be here for this region, but it could be here, or it could be either of these two. That seems fine. Hmm. Yeah, I really don't understand this Heyawake very well. Or I don't have, sorry, I understand it. I don't have intuitions about it. Remaining digits of row 1. We have 1, 5, 6, 7, 9. Obviously no 1 there. Remaining digits of column 8. 4, 5, 6, 7, 8, 9. No 6 here. It's not very restrictive there. Oh, the rate. Okay, red cells half digits in the remaining shaded cells are greater than at least 2 of their orthogonal neighbors. So this is 1, and this could be 1 here. This is definitely greater than 1 and 3. That's fine. Oh, that's interesting. Huh, yeah, so this can't be. Anyways. This could be if it's 2 and that's 1. That's interesting. This cannot be shaded. Because if this were shaded, it's not greater than 4. So therefore, it's not going to be, so that's not greater. So that cannot be shaded. 2, all the 2s, well, no, 2 could be greater than 2 1s. All the 1s have to be unshaded. Oh, so this can't be 1. Okay, that's helpful. So then, well, Not too helpful. Oh, wait, no, this could be 1. Because it's given. And that rule does not apply to it. Okay. Interesting. I totally forgot about that, though. This is 2, so it cannot be shaded here. If this were shaded, it only has 1, 1 that it can be greater than. So this is unshaded. 2 could have a 1 there and a 1 there. This 2 cannot be next to 2, 1, so this is unshaded. This is given, so we don't care about that one. 2 could have 1 and 1 there. That is possible. This 2 is not greater than any of these, so this is unshaded. Aha! So you could have shaded, shaded. It can't be shaded, shaded here. Because that forces this to be unshaded. It has to go out that way. What about shaded, shaded there? That seems okay. One of these 2 is shaded. So say it's shaded here. If this is shaded, these are unshaded. And then we only have 3 shadeds in this region, and that's not allowed. So this cannot be shaded, which means this is shaded. So this is shaded, this is unshaded. It cannot be shaded here because, again, this can't be unshaded. This has to be... If this is shaded, this has to orthogonally connect. These can't be shaded because we have 4 already. And this has to be unshaded because it's shaded there. And therefore, this would be crossing 2 boundaries. So this cannot be shaded. It's unshaded here. This has to orthogonally connect to the other unshaded region. So one of these 2 is shaded. This is 2 unshaded, which means it crosses here, and therefore this cannot be, this has to be shaded, which means these are unshaded. One of these 2 is shaded, which means this has to be shaded there, which means this is unshaded there. So one of these 2 for 3, one of these 2 for 4. We have shaded, shaded, or sorry, unshaded, unshaded, so this must be shaded here. Which means this must be unshaded, this has to orthogonally connect. This must orthogonally connect. But it could orthogonally connect that way. That's fine. This has to be greater than 2. It's greater than the 2 here, but if this is 4, it would be less than these. So this cannot be 4. This can't be 4 because of 4 in the column. So if this is 5, it's not going to be less than either of these, so this can't be 5. This, if it's 4, has a problem because none of these are less than it. So this can't be 4. This can't be 1 here because it's orthogonally, okay, shaded. 1 is not in the shaded cells, period. If we had, well, we could have red, red. That is possible. No, you cannot have red, red. If this is red, red, then this cell is blocked off. So if this is red, this must connect green there. If this is red, this must connect green here. So this is always green. So we have green here, this is red. It must be greater than 2 out of the 4, the cells that it shares an edge with. So this is 1, and this is green. So eliminates 1 in the rest of the row. This can't be 5 for the same reasoning. One of these is red, so then it connects orthogonally here. One of these connects orthogonally. Okay. This has to be red. If it's green, that's going across two lines. So this is red. This is green. This cannot be part of, this is green, so that cannot be part of this region here, because if it were, then this would go across two boundaries. So therefore, it must be there, which means this must connect there. So we can, this is green, this is green. That's fine. This must be greater than 3 cells. It could be 1 here, but it cannot be 5 here. If this is 5, these are not less than it. This is not less than it. So this is already greater than both of these, so that's fine. This is given, so we don't know what that is. One is one of these two, because one cannot be here, here, or here. So since one is one of these, this can't be 1, it's 4, which means this can't be 4 here. There's no 4 here. Where is the 4 in this region here? It has to be here. So this is 4, which eliminates 4 here. We need a 4 in this region. This is 5, 7, 8, and 9 as a quadruplet. This 5, 7 then means this has to be 5 or 7. And this must be 4. Which eliminates 4 in the rest of the row. That's fine. This is 4 here. Okay, so row 1, this is no boundaries, no boundaries, no boundaries. Row 2, 1 boundary, no boundaries, 1 boundary. Row 3, no boundaries, 1 boundary, no boundaries. Row 4, no boundaries, 1 boundary, 1 boundary. This is 2 blue, 2 greens, so this must be red here. That makes this green here because we have 3 of these, and this is green. Okay. So we don't know if this is red or... So this is red. It cannot be 1. Whereas 1 in this region, it has to be here. And this is necessarily greater than both of these. So that's going to be fine. Remaining digits in row 5, 5, 5, 7, 8, 9. One has to be one of these 4 also. So we have 1. This 4 eliminates 4 here, so this is 1. Okay, well, there we go. We have to have 4 in one of these 3 because we don't have 4 available in the rest of the region, so this cannot be 4 here. This then has to be 5, 7, 8, or 9. And this is 4, 5, 6, 7, 8, 9. No 4 here. So one of these 2 is 4. This can't be 4 here. So where's the 4 in this region? It has to be here. So this is 4. 1 eliminates 1 here, so it's 4. No 1 or 4 here. This has to have 4 shaded cells. So one of these 2, one of these 2, one of these 2, and one of these 2. Interesting. Huh. That means this can't be 4, so this can't be 5 here. This is guaranteed to have an 8, which eliminates 8 in the rest of the region and the rest of the row. That's not that helpful, though. 4 cannot be any of these, but 4 could be here. This cannot be 1. We have 5, 7, 9 as a triplet in column 4, which eliminates 5, 7, 9 in the rest of the column. Oh, this has to be 8 and 7. That's fine. Right, this is 1, 2, 3, 4, 5, 6, 7. So no 7 here, no 7, 8 here, no 7, 8 here. This is no 7, 8 here. Okay. One of these is 1 here. We're not sure which. We have 1, 5, 6, 7, 8, 9. Okay. This is 2 boundaries here, or 1 boundary here, so this has to be red, which makes this be green, this be green here. So since this is green, we need to have red, green, red, green, red. So red, green, red, green, red. This is green. These are green. This is green. We have 2 right now, so either this is red or this is red. We're not sure which. We have 1 across. If this is not red, then this is green, which means this is crossing 2 boundaries, so this has to be red. Green has to orthogonally connect. Green has to orthogonally connect. That means we have 3 shaded in this region, so this is green. Hmm. Okay. These are all unshaded, so we need 2. So this is shaded, which means this to orthogonally connect must go all the way around here. We have 2 shaded here, or 2 unshaded here, therefore this must be shaded there. This must be greater than 2 cells. It's greater than 3. It must be greater than a 1. No 4 here because of 4 in the row. We need one of these 2 to be shaded, and this is going across 1 line, so this must be shaded, which means this is unshaded. This is great, must be greater than 3, so this cannot be 5. Okay. Sorry, it must be greater than 2. And if it's 5, it's not greater than any of them. This is orthogonally connected now. We have 1, 2, 3. 1 out of these 2 is shaded. This cannot be 1. Where is 1 in row 7? It must be here. So this is 1. Okay. These cannot, so these digits are 1 through 4. No 2, 3. 1, 4, 5, 6, 7, 8, 9. Obviously 4 cannot be any of these. Where is the 4 in this region? It has to be here. That means, and 1 cannot be either of these because this must be next to 1 digit that it's greater than. This, one of these, whichever one, so this can't be 1. We need access to a 1 for this region. So this must be the 1 here. And so this is part of that region. So that's done there. This sees 7 cells. So this is 7. No 1 here. This can't be 1 here, which means 1 has to be here. No 7 here. No 7 here. This is 5, 6, 8, 9. So this has 1 shaded cell. This can't be shaded because this is a 1. Okay, let's remove the coloring here. This is green. These cannot be shaded. So this must be shaded here, which means this is unshaded. This has to orthogonally connect to the other unshaded cells. Okay, so now we have most of this done-ish. Okay. Let's see. So 0 boundaries, 0 boundaries, 0. 1, 0, 1. 0, 1, 0. 0, 1, 1. 1, 1, 1. This is 0, 1. That's fine. 0, 1. This is fine. This is 1 at 1. 0, 1. 1, 0, 1 at most. So we don't have anything there. Okay, so this cannot be green. If this were green, the problem is this would be across many boundaries. So this has, yeah, this is one boundary here. So this has to be red, which means the rest is green. Okay. So 7 eliminates 7 here, no 7 here. Okay. This is 5, 7, or 9 also, which means where is 6 in row 7? It has to be here. So 6 is consecutive with 7 only, which means this can't be 7. No 6 here. So where is 6 in row? Well, okay. No 6 or 7 here. Okay, let's do boundaries again. 0, 1, 1, 0, 1. 1, 0, 1, 0. 0, 1, 0. 1, 1, 0. 1, 1, 1. 0, 0, 0, 1. 0, 1, 0, 0, 0. Okay, so we're all done, and I think all the greens are orthogonally connected. The reds are, yeah. Yeah, the greens are all orthogonally connected. So now we have to use the shaded cells, which are not given, so these don't match, have to be greater than at least 2 of the cells that share an edge with it. Okay, so this is 5, 6, 8, or 9. 6 is guaranteed to be one of these 2 digits, so that eliminates 6 from the rest of the box, which means 6 has to be one of these 2 digits, which eliminates 6 from the rest of, region. 5, 9 matches 5, 9. 7 has to be one of these, which means this cannot be, well, okay, that can't be 7. Where... Okay, this is greater than 3 and 2. 8's going to be greater than 7 and that cell at least. This could be greater than 1. Oh, 1 eliminates 1 here. And that forces this to be 1 here. And this can't be 1. Where's 1 in row 1? It has to be here. So this cell's always going to be greater than those 2. Same as that. That's going to be greater than 1. This is a given. That's given. This is greater than 2 and 1. 8's greater than both of these. This is greater than 4, and it's going to be greater than this cell. This is greater than 2. We don't know about that one, though. This is greater than 2 and 4, so that's satisfied. This is greater than 1 and 1. That's satisfied. Greater than 1 and 1. Greater than 2, 1, 1. Greater than 2 and 1. This is given, so we don't care. 4 is greater than 3 and 1. 6 is greater than 2 and 3. 7 is greater than 6. One of these has to be a 5, though. This is greater than 2 and 4. This is greater than 2 and 4. This is greater than 2 and 4. This is greater than 4. But we don't know about these. Okay, so 7 eliminates 7 in the rest of the column. Okay. 8 has to be one of these two. 8 in this region must be one of these three, which is in column 1 and 2. This is in column 1 and 2, which means you cannot have an 8 anywhere else in columns 1 and 2. So no 8 here, no 8 here. One of these two is an 8, which eliminates 8 from the rest of the column. So no 8 here, no 8 here. This 7, 9 is consecutive with 8 here. So this can't be 8 here. One of these two, again, is 8. One of these digits is 5. Does that help? I don't really know. This matches that cell there. Okay. Let's mark these. So again, that's greater, 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 and greater. This is greater than all of them. That's greater than both of those. Greater than that, greater than that. We have one greater than that. This is greater than that and that. Greater than, let's just use these two. Greater than those two. Greater than those two. Greater than those two. Greater than that. We don't have anything else. Greater than that and that. Greater than that. Greater than both of these. Greater than both of these. Greater than both of these. This is greater than both of these. Greater than both of these. These don't matter. So the only ones we have that are still kind of up in the air. Oh, one of these is going to be less than it because you can't. One of these has to be 7, right? Or 5. So this is guaranteed to be one of those, so that's fine. 7 has to have a 5 either here or here. That doesn't really help us much. If this is 5... Okay, yeah, it does help us. One of these has to be 5 to be less than this 7. So if this is 5, that's 9, and then this has to be 9. Because the digit missing here is the same digit there. And if this is 5, that has to be 9, which makes that 9. So this has to be 9 here, guaranteed. So this is 9, which eliminates 9 in the rest of the row, columns, regions. So this can't be 9 here, it's 5 or 8. 9 cannot be here. 9 is one of these two, which eliminates 9 from being one of those two. This is necessarily going to be greater than that, so that's fine. So this matches that cell there. Cannot be 9. So it's a 5-6 pair, which eliminates 5, 6 in the rest of the column. So this can't be 5 or 6. It's 9 there, which eliminates 9 in the rest of the box. Our region. Also, 9 eliminates 9 here. Therefore, where's 9 in column 1? It has to be here, which eliminates 9 here. There's no 9 there. So 9 has to be one of these two cells here for this region, which means this cannot be 9 here. One of these two was a 9 there. That's fine. And the rest we're just trying to figure out from Sudoku. So this is the same digit as that. So this is guaranteed to be next to a 5. So we're guaranteed a 5 has to be one of these digits here in this region. Oh, it could be here. Never mind. Never mind. Hmm. Hmm. Okay, so what are these digits? Okay, so let's remove the greens. This digit, we'll mark it as blue, has to be the same as that digit there. That means it cannot be here. It has to be the same as that digit there. Has to be one of these 4, but that's not helpful. This is orange. Okay. Hmm. Okay. I don't know how helpful this is. This is 5, 7 as a pair, which eliminates 5, 7 in the rest of the column. This can't be 5 or 7. It has to be 9. Which makes this 7, which makes that 5. Okay, that's helpful. No 7 here, no 7 here. No 5 here, or 6. No 5 here, no 5 here, so that's 9, which means this can't be 9 there. That eliminates 9 from the rest of the column. Hmm. Okay. Blue can be one of these 3. We're not sure which. Blue can't be here. Blue can't be here. Blue's one of these 3 then. So blue has to be one of these 2. Because it can't be here. And it can't be 7, 9. So it's one of these 2, which means blue cannot be that one. So blue in this region has to be here or here. Which means that can't be blue. That's pretty broad. Hmm. Blue is either here or here. Which means this can't be blue, this can't be blue, so blue is either here or here. Hmm. Blue has to be one of these 2. Blue is... cannot be here. So blue is one of these 3. Okay. Does that help us? I don't really know. Blue's one of these 2, obviously. That's not helpful. Hmm. Um, hmm. Orange is one of those two. Orange must be one of these two here. Orange must be one of those three. So then orange is one of these three. Orange is one of these two. That's not helpful. Ugh, this is kind of painful. Okay, we have a 5-6 pair in column 3, which eliminates 5, 6 in the rest of the column. This can't be 5. It's 7, which makes that 9. So this can't be 7 or 9. It's 5 or 8, and that is the blue 5, 8, because this can no longer be. Which means blue 5, 8 can't be here, blue 5, 8 can't be here, blue 5, 8 must be here, which means this can't be 9. Whereas 9 in column 6, then, it has to be here. So this is 9. Oh, we already kind of figured that out, I guess. Huh. So we have blue, blue, blue. One of these two is blue. Obviously one of those two is blue. One of these three is blue. Blue cannot be here. So blue cannot be here. Blue, where is blue in this region? These are not 5 or 8. This can't be blue. This can't be blue. So this must be blue, which means all the blues are 8. So all the blues are 8. All the oranges are 5. This can't be 5 or 7. It's 9. This can't be 8. That means this can't be 8 here. 8 eliminates 8 here, so this is 6, which makes that 5. Which makes that 6, which makes this 5, which makes that 7. 8 eliminates 8 here, so this is 7. This can't be 7 or 8, it's 5 or 6. This can't be 8 or 7, so this is 5. 5 makes a 6, which makes that 5, which makes this 6, which makes that 5, which makes that 7, and makes this 6 and 5 there. 7 eliminates 7 here, so it's 5, which makes that 6, and this is 7. Woo! That was a doozy. Yep, very hard. Surprisingly, the chaos construction was rather simple. Besides, yeah, it was just the Heyawake, and then getting the numbers, the execution of getting that was kind of difficult. But, I don't know. Never felt like I was stuck, but it was also not... It was definitely a very hard puzzle, I guess I should say. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.